So before we can jump to discussion of the actual grammar, what we need to understand as the first order of business in this application is that as we are given this input, we have to, so this input is given to us as just a string that contains these symbols. And we need to tokenize this. In other words, every symbol that is meaningful and can be used in the construction and the analysis of the grammar of this input, it has to be recognized first. So parentheses, like in this opening parentheses, numbers, operators, all of this has to be understood before, or tokenized, and each token will be assigned its type before we can proceed to formulate and begin to analyze our grammar rules. Okay, so an input like this has to be split into numbers, arithmetic operators, and parentheses that specify sub-expressions. Of course, parentheses are very important because here these parentheses play a very important role. Without parentheses, we'd be multiplying 6 by 2, which would be 12 plus 1, so that would be 13. But that's not what the user wants. The user wants to add 1 plus 2, which is 3, multiplied by 6, which is 18. So the role of parentheses here becomes very, very important to the user. So anyway, so these are all components that we need to tokenize and assign their types. So we have the class name TokenStream in this prototype that splits the user input into an array of Java strings, but instead of just taking a single string like this, it will contain each part of this token stream will be a string. This string, and it will contain individual tokens. Right? So that makes sense. So this is just an array of strings like this. I just write it down like this to show you this single string results in a combination of those little pieces, which we call tokens or input symbols. This is also an acceptable term for this type of data. So this is what TokenStream does. It takes the string and generates an array of strings that represent individual tokens. So TokenStream provides operations to navigate the sequence of tokens. We can say go to the beginning, which means jump to the first token. We can say next, which will take us to the next one. And we can always check whether we are at the end. So if we're at the last token, we can always ask, is this the end? Which means that there's nothing else beyond this. So we can always check whether there's something else remaining, or it's really the end of the token array. There's some also methods to analyze the data inside the token. So the program, so once this array of strings is created, we can say get string, which will simply return the string from the token. IsString compares current token to a specific string, so we can compare plus to plus, 2 to 2, and so forth. And we can also check whether it's a number. Okay, so we have to recognize the numbers, and they play the role of values that our operators will be applied to. So we have this simple idea of is this a number? So this is pretty much the whole idea behind the TokenStream. So let's take a look at the code for TokenStream. So right here we can look. So what kind of data does it contain? It contains the index of the current token. Remember that we're going to support begin, next, and is end. So obviously this internal token index pointing to the current token in this token stream, because this TokenStream class provides access to the sequence of strings in terms of one at a time. And so that's why we keep the index. String builder is used to contain the actual original input. So we have string builder here, which contains the initial input. And these individual tokens are going to be stored inside the array of strings. So that's pretty simple idea. Now the TokenStream right here is accepting the string builder with the user input text. Right? So this input right here will be given to the constructor of the TokenStream, and TokenStream wants to get a reference to string builder, and it simply remembers the input reference inside here. So the first operation here, which is simply converting this initial input into a series of small little strings representing individual tokens, is called Tokenize the Input. So we take the string builder object right here that contains this input, and in a loop we analyze individual characters. So essentially what we do is that we create an index. We start with 0. And we go to this input. String builder is very similar to string. It's just dynamic string that can be modified. And for the entire length of input, what we do, we extract each character from the input. We look at each character, and we try to make a decision based on every character that we get from this input. Character by character, we analyze this, and the result of it is that we're going to split everything into a series of tokens. So look what here is being analyzed. We say, is this a digit? Is this a letter? Is this an opening parenthesis or a closing parenthesis? Is this punctuation? So we just take a look at different types, and every time we detect different types, we realize that, oh, this is a parenthesis, therefore it should form a token, and this is a number, therefore it also should form a token. And as we go, we will accumulate individual tokens. Of course, these numbers don't have to be single digits. They can be numbers that are floating numbers as well. For example, if I run it again, I can type something like 3.14. Okay, so this tokenization understands fractional numbers as well. So we can use the period, the radix point, for formulating fractional numbers as well. I'm just going to close these running instances and go back to our handout. All right, so next part of token is there is this debug method that prints tokens, and it's just used for debugging. There is a method that checks a character, whether it's a punctuation. So there's a character helper class, and of course it has is digit, is letter, or is whitespace. So we check whether it's a digit, is letter, or is whitespace, and if it's not, then it becomes a punctuation. There is no check for punctuation, unfortunately, inside the character class, so we have to exclude these digits, letters, and whitespace. There is a helper method, skip empty tokens. It's just used internally. You can see that it's a private method inside this tokenizer. Then begin simply sets token index to 0. And next increments the token, and is end basically looks at the length of the token and determines whether we're just actually looking at the last token in the array of tokens. This array of tokens is just simply an array of strings. So getString simply returns the token. isString checks whether the specific text equals our token, and isNumber gives us answer whether it's a digit. Okay, so that's all pretty much what we have in this token stream, and this is how it's organized.